4.2, we are going to take what we have learned in 4.1 one step further, and we're going to set it equal to 0 and solve.
Are you kidding me?
So, I want to take a general poll. If you can think back to 8th grade, like in your mind. Or when you took Algebra 1. Either or. When you took Algebra 1, have you ever seen
Algebra 1 sounds so bad.
this? Zero product property.
Yes.
No,
Yes.
no,
Good. That gives me hope. Okay. Because in Miss Napier's class, they said that they had never heard of it. But I just think that they're a lot dumber than our class. But
I heard that. I know all about it.
so what that means is when you start graphing, so most of the things we've seen are parabolas, right? Or x squared. And when you start graphing them, zero product property, that just kind of means where it hits the x-axis or where the x-intercept is. So when you're setting it equal to 0, you're solving. So if you say that a times b equals 0, then a equals 0 or b equals 0. But if we look at the next one, if a times b equals 10, then a equals 10 or b equals 10. Is that a true statement or is that false? That's false. So that is why we always have to set our equation equal to 0, then solve. So if you're setting it equal to 10, then it could be true, it could be false. So we're going to start with an easy factoring one. It's already set equal to 0 for us. So let's factor.
So we're solving for x.
I'm going to show you how to solve for x. The first step is just setting the equation equal to 0, then factoring it. Okay, so I'm going to factor the left side. What would that look like? So, what two numbers multiply to get 6? 3 and 2. The signs will both be negative equals 0. So I've now factored it. They both equal 0. From here, I'm now going to set each parenthesis equal to 0. So x equals 3 and x equals 2. Because imagine, and I'm going to show you the long way, but honestly, you're just taking the opposite sign. So I can look at it and say that it's 3 and 2. The long way is you're saying x minus 3 equals 0, and x minus 2 equals 0, x equals 2. That's the long way. I'm just going to look at it and identify that it is 3 and 2.
And so if it was x plus 2 and x plus 3,
It would be negative 3 and negative 2. Yes, perfect.
So will there always be 2 answers?
Mm-hmm. Yes,
Wait, that's
when
it?
you're solving by factoring, yes.
That's it.
Mm-hmm. Okay, now b, it's not set equal to 0. So what do I need to do? Subtract the 26. So 4p squared minus 26p plus 40 equals 0. Now I'm looking at it. What's the first step always? Step 0.
Find a common factor.
Find a common factor. Can I take anything out? Take out a 2.
Does it matter where the 26 goes?
I will always put it in the middle because that's how it looks like when you're factoring.
Has to go in the middle. Okay.
Because it's like descending order.
Okay, now I want to factor this stuff in parentheses. So, go ahead and do so. And another thing you could do in between this step, if I've pulled a 2 out and I divide each side by 2, what happens?
Then the 2 cancels out.
The 2 cancels out, and then 0 over 2 is just what? 0. So I can just say, I don't even need the parentheses. I can just say 2p squared minus 13p plus 20 equals 0. That 2 can just go away when I factored it out.
Oh, it just goes
Anything
away.
you factor out
Can go, if it's just a number, it can go away. If it's an x, then no.
Okay.
So try factoring that. So how would I factor this? It would be what? 2p minus 5, p minus 4 equals 0. When I set each parenthesis equal to 0, I end up getting, so if I say 2p minus 5 equals 0, p equals 5 over 2, and then p equals what? 4. So that would be my final.
Okay.
I'm going to encourage you to not do this step. Just look at it. You can just look at the parenthesis and imagine setting it equal to 0. Move the 5 over, divide by 2. So positive 5 over 2. Don't waste your time doing that last step. How would I factor this one? For C. 4m minus 5.
I think I would be sick that day.
Then you set them both equal to 0. So m equals,
Positive 5 over 4 or and then negative. Okay.
perfect, positive and negative 5 over 4. You could also write it like this,
The plus and
plus minus 5 over 4. Either one. You want to feel fancy, you can do the plus or minus. Okay, for D, we are going to set this equal to 0. There must have just been a little typo. What can I do here? I can take out x squared, and then I'm left with 6x minus 1. So this is a common factor kind of problem, because can I do anything further from here? No. So I'm going to set each part equal to 0. I'm going to set the x squared equal to 0, and the 6x minus 1 equal to 0. So when you pull out a common factor that is not just a number, you can't divide it out. So if x squared equals 0, then x equals 0, and x equals 1 over 6. So there are 2 methods to solve the basic quadratic equation, which what I mean by that is just that there is no middle term. Like there is no x.
Oh, this one.
This is my kind of math right here.
So A and B both have a middle term. C does not. So what do I mean by middle term? Well, yes.
Just an x. Like x.
So if I said like x squared plus 2x plus 4, or I just said x squared plus 4, the middle term is this. Yeah. So to solve with something like this, you would have to factor. Like the top one, you would have to factor. To solve the bottom one, there's 2 ways that you can do it. You can either factor, or you can just move it to the other side and you can square root. So I'm going to show you both ways, because there may be one way that you prefer. The factoring way would look like this. And I would factor that how? Difference of squares, which looks like x plus 4, x minus 4. So my answer would be negative 4 and 4, or plus or minus 4. The second way is called the square root method, where I square root, but you have to remember that x equals plus or minus 4, because 4 squared and negative 4 squared would both be a positive 16. Right. But remember, like I said, this only works if you don't have that middle term. So if you just have an x squared and a number, or an x cubed and a number. Or I guess an x and a number, but that doesn't usually happen. So use method 2, and method 2 was the square root method.
Oh my goodness.
So use the square root method to solve the following. So I'm going to do A, and then I will let you do B.
Yeah, that'd be great.
Okay, so A, I'm going to square root the left, I'm going to square root the right. When I square root the left, I get x minus 2 equals plus or minus 4.
And we do it again, and it's
Then I'm going to add, I want to get x by itself. So x equals 2 plus or minus 4. So what are my two answers? 2 minus 4 is negative 2, and 2 plus 4 is 6.
Are any of the problems that we're learning today, will they ever have only one answer for what we're learning today?
Mm.
Okay.
So try this method on part B.
so here's where I'm confused.
Can't freaking.
You know, it gets tricky when you're trying to square root 3, let me tell you.
Nope. Just plus or minus, just leave it square root of 3. Don't need to do anything with it. Just leave it like that.
You can just do that.
Mm-hmm.
Question. Why wouldn't we
Oh my
equal
gosh, why?
zero?
Why did I think that was so easy?
Because we can't factor when it looks like this.
Okay.
So on these types of problems, you won't try to factor it because it's already factored as much as it can be. So it is up to you to discern, like, does this problem look like something that I have factored before? Or does it look like something like this? In this kind of case, where you have something in parentheses squared equals a number, you're going to use the square root method. But you're going to use the factoring method if you've looked at it and it looks like something you have factored before. So then x equals negative 1 plus or minus the square root of 3. And then that's your final answer. That's as far as you can go.
I did x equals plus or minus the square root of 3 minus 1.
That's fine.
Okay.
But when we start graphing, you want to get in the habit of it always, the number always being first.
Okay.
Because, and the reason why I say this is because it starts looking like the quadratic formula, which we're going to get into next lesson.
Negative b plus or minus.
Negative b plus or minus square root, yes.
What are our imaginary numbers, like do they just not exist?
I forgot.
I'm going to show you.
I forgot the quadratic.
Wait, what? Imagine what?
If you had a calculator, would you have to go further?
Imagination.
If you had a calculator, would you have to go further on that one?
Nope, you leave it like that. I don't want it, and I don't want any decimals. Decimals are gross. Okay, the last method is solve by completing the square. Have you ever seen completing the square before?
No. I'm on
No, this is the first time. Oh, I'm excited.
a, I'm on a different part.
I don't know. This is the back of the notes.
That's probably what happened.
Oh, it goes A, B, and then goes C.
Does everyone have it?
I don't think I.
I have a test on
Completing the square.
Delete.
I have this. It cannot be factored. So, what I'm going to do, you can try to factor it, but you cannot. So I'm going to complete the square instead. The steps are written to the right. You are going to isolate the x terms. So what that means is I'm going to move this 8 to the right. So x squared minus 4x equals positive 8. From here, I'm going to take half of my b term, or half of this, and then I'm going to rewrite as x minus 2 squared. So set it up, and this plus or minus, it'll always match the middle term.
Okay, where did the x for the 4 go?
Yeah.
So the long way, I don't know, these notes are kind of interesting. So
What?
I think I'm gonna show you the longer way. I'm gonna show you the longer way, and then I'll show you the shortcut, because I feel like it's confusing if you don't know the long way first. So minus 4x, put plus blank equals 8 plus blank, and then I'll show you why here in a second. The second step was to set up x plus or minus 1/2 b squared. So I told you that that was x minus 2 squared. So just write that underneath, and I'm going to show you how we got that in a second. When you take your center term, I want you to divide that by 2 and then square it. And what number does that get you? 4. So half of 4 is 2. 2 squared is 4. So put a 4 here and a 4 here. If I were to factor this, this is called a perfect square. Because I want you to just try to factor that. I've got my 2 parentheses. The signs are both negative. X, X, and then what numbers would go in the last blanks? 2 and 2, which is the same thing as this, right? X minus 2 squared. So what you're doing by completing the square is you're creating a perfect square to then factor it. But whatever I add to the left side, I also have to add to the right side. So I get, when I factor it, x minus 2 squared equals 12.
Okay, so how we find the number that goes in the blank?
You half the middle term, or you half this term.
And we don't include the negative.
You did include the negative, because you halved it.
So, that's
Mhm.
what we have. We have to say 8?
No, you half the negative 4.
Wait, so is x minus 2 squared equal 12 the answer?
So then whatever this number is, you square it to get the plus 4 on the other side.
Okay. And you put it in this.
So you square the 1/2 b and add to both sides.
So which one is the answer?
I'm so confused. So is x minus 2 squared equals 12 the answer?
So then we're going to solve it like we did the last one, where we square root both sides and then solve for x. But let me go over completing the square again, because y'all are confused.
Yeah.
Okay? I'm going to erase the whole thing. And I'm going to take this step 3, and I want y'all to move that to step 2.
How do we know that it wouldn't work, so we have to do it?
Because if you try to factor this, it would not work.
So you have to do that.
So you have to complete the square if you can't factor it.
So how do we know?
But like, yeah, how do we know?
Just try and error. Unless there's a specific a specific header on the test that says complete the square or factor, but that may not happen.
This is gonna take forever to finish.
No, it will not. Okay, so here's what I'm doing. Isolating the x term. X squared minus 4x. Then you put plus blank equals 8 plus blank. So this is how I set it up every time. I move the number over and I put plus blank on both sides.
Will it always be plus blank?
Yes, always, always. And you're always adding plus blank. It's never minus blank.
Because you have to square root it, and if you square root a negative, it's going to be a positive.
Right.
Square root of positive, it's gonna be a
You always want to create a perfect square, which would mean that you have to have a plus on the right, on the last term. I'm going to take this center number, I'm going to cut it in half, and then I'm going to square it. So half of -4 is -2. -2 squared is 4. And I add that to both sides.
So Mrs. Thornhill,
Mm-hmm.
what if it's an odd number? Do we just have to?
It would be like if it were
3 divided
3
by
halves, and then 3 halves squared would be
Okay.
9/4.
one.
You won't really see many fractions just because
Good.
they're mostly going to be even numbers.
Is there anything about the middle term that we go and we say, oh, this looks like itself by completing the square? So for whatever reason, something along the lines of only half and square it lets us know that you could actually factor out the whole thing. I'm just asking if there's like a
Where does it
quicker
tell us
trick
to
to
divide
see if
that
you can
by
factor
two?
out the whole thing instead of having to try to factor out the whole thing and then saying,
Like
oh,
completing
no.
the square will always work no matter what.
Okay,
Mhm.
just complete the square.
Okay, from here, if I factor this, so from here I'm going to factor, and you get x minus 2 squared equals 12. Then I'm going to square root each side. And you get x minus 2 equals plus or minus the square root of 12. Don't forget the plus or minus. Then I move the 2 over to plus or minus the square root of 12. And I leave it like this, except for the fact that I can simplify this. Go back to your Algebra 1 skills.
3 to 2 or 4 to 3,
Pull out a perfect square.
which would be
4. So 4 times 3, and then this comes out. It escapes jail or whatever y'all used to say.
2
Are
squared.
we seriously doing this?
Yes.
This
This will be your final answer.
If we don't do that,
Yes.
Are you serious?
It needs to be fully simplified.
What if like it's an odd?
If it's like, yeah, if it were square root of,
15.
5.
yeah, then you would leave it like that.
Okay, can you make them all like that?
No. So all you do when you're simplifying is you look and see what perfect squares are inside, you pull those out.
okay.
All right, let's try the next one together, and then I will give you one to do on your own.
Yeah.
Where it goes outside.
Okay,
I just don't understand that.
just take some practice, okay?
Yes, ma'am.
So I'm going to move this over. 4x squared plus 24x plus blank equals 13 plus blank. Now, in order to create a perfect square, this number, like this first term, needs to just be, like it cannot have a number in front. So you notice how in the first one it was just x squared. So in the second one it has to be just x squared. So I need to divide everything by 4. Left side and right side.
I don't like this.
It's okay.
It is 157 times.
If I divide everything by 4,
There's a fraction.
that's okay. Don't be scared of fractions.
Just looking at numbers.
Plus blank equals 13 over 4 plus blank. Leave it as a fraction.
So wait, why do we have
the middle term and then
square it?
So it'd be 9.
Okay, 6 is my middle term. What's half of 6?
3.
What is 3 squared? 9. Add 9 to both sides.
So, quick question.
Mm-hmm.
What if I did 2x plus 12 squared?
You still cannot have,
Wait, so you said what is?
you cannot have a number in front of x squared.
So you said what is half of 6, and then we said 3, and then you said what is 3 squared, and we said 9.
And that's where you put the 2.
The blanks.
Mm-hmm.
You divide by 2.
So what goes in the blank is not like square root, but half of the middle term squared.
Yes. Then I factor this to be x plus 3. That's why I wrote the 3 underneath. Squared equals whatever 13 over 4 plus 9 is. I'm going to go ahead and erase this 9 and write it with a denominator of 4. What would that be?
20, no.
What's 9 times 4? 36. So 36 over 4.
What happens to the first 9?
It got factored. So this whole thing got factored to be this.
So why did we get 36 over 4?
Because you want to be able to work with the 13 over 4.
hmm
But why did we do 9 over 4?
Because 9 over 4 is not the same as 9.
But it's plus 9 in the blank, so why would you do it divided by 4?
Because I want a common denominator.
But doesn't that change the number?
No,
Isn't 36 divided by 4 the same as 9? You can try it in your calculator.
it is.
Because
But
9
then-
over, you just do 9 over 1 and then times it by 4.
hmm
And then you get 36 over
Then why are we doing it by 4?
Because I want to be able to add these. And I can only add them if they have a common denominator.
So we're allowed to like change that number?
Yes, you should change that number. So I'm going to give myself some more room. So now what I'm working with is x plus 3 squared equals 49 over 4. I want you to try and solve this by square root. It turned out pretty nice.
By square root.
Wait, so
Square root both sides. You don't need a calculator.
Does
does
just
it get
stay
to
under
a
the-
7 outside of the square root?
Oh,
wait, 7 over 2.
Yeah.
7 over 2.
okay, and so once it's 7 over 2, do we just leave it right there?
How is that
Well, it's plus or minus, and you got to move the 3 over.
7? The square root? Oh.
It's like a,
Okay, let's go to C.
it's November 14th.
What?
The test. It's far.
Yeah, it's not for a while. Okay, let's go to C. What's my first step?
Do the blank thing.
Right? Yes. So I have negative 3x squared plus 6x plus blank equals 1 plus blank. What's a problem that I see?
There's a negative 3 on version as divided.
I gotta divide everything by negative 3. So x squared, what does the next term become? Plus blank equals
Oh, you divide by 9.
negative 1 over 3 plus blank. Okay, I want you to try the rest of it. So on part B, it was like equals 49 over 4. When we square root that, we end up getting 7 over 2.
Okay.
So why is it?
In this case, it equals 2 over 3. When you square root that, nothing gets simplified from there. So we leave it as the square root of 2 over 3.
And that's why you can't have more than 2.
Right, so I can't do anything further than this right here.
So
I
if
have to
there-
stop.
So if there is nothing on the x squared, does that mean we just don't divide anything?
Right.
by it?
So for D, it's already nice and neat for you because it's just x squared. So try the full thing, start to finish.
I don't want to look. Hang on. It's
But if you
In this case, you got a negative on the right side. And anytime you square root a negative, it becomes an imaginary number, which we're going to talk about next class. For now, in this kind of purpose, anytime you have the square root of a negative number, we would say no real solutions because it becomes imaginary. You cannot square root a negative number.
But next class we're talking about imaginary.
Yes.